in any trace file, you should see. I will teach you today that how to know the columns of any trace file if you don't know. Okay. So, if you don't know the columns, suppose a random trace file is given to you, or you are running a TCL file and randomly it is generating a trace file, then how you will know that this trace file and what are the columns of this trace file. Okay, so I will open the trace file first, then we'll talk about it. Because trace files format is different for all the networks. Okay, so you will have to understand means you should know that how I can deduce the columns while only looking at it. Okay, I will give you some tricks for that. Okay, this is something, it is happening M10 something like this, it is happening. So you can see this comma this, we have provided the scenario part means 5000 cross 5000 meters. Okay, suppose you don't know what this trace file does, means what are the columns this trace file having. So we are just guessing now. So this is below 5000. Okay, so this is also below 5000. See the same columns. All the values in this column is below 5000 only. So what we can deduce, this is the coordinates of that node. Okay, which node? The node address will not be same for two positions. So here you can see the third column 0, 1, 2, 3 like this it is starting and up to what? 149. Okay. So you can understand that this is the node ID. Okay. Now this is the coordinate. The third value what we give generally, it is velocity obviously. So it is the velocity. At the initial point the velocity is 0. Now what this coordinate may show? This may be the coordinate of the destination and this is the velocity. Why? Because this value is always less than 50 and we give the maximum velocity as 50. Okay. This one is time. Okay. 1 second means at 1 second we wrote that the node ID is, I hope everything is clear to you up to here. The node ID is defined in a sequential manner. Okay, it is different from the node name that we are giving. Okay, we are giving node number 0 to 149 here, and here in trace file also we are seeing 0 to 149. But if we generate from 5 to suppose 149, okay, then also 5 to suppose 5 to 154, then also these numbers will be starting from 0. Okay, whatever value you are giving here, 0, 1, 2, 5, 10, 11, it doesn't matter. Whenever you are creating the first node, it will be automatically assigned the address 0, address 1, address 2, or ID you can say, address 3, 4, 5, like this it will assign in a sequential manner. If you want to give it the value, the number you want, then you will have to go into the source code and change some lines in it. Okay, because in the source code it is written, even if you assigned any address to it, it will be converting it in a sequential manner. Okay, so that is why it is done. Now, okay, Actually, these lines are nothing. These lines are not used in the simulation. These are just when the nodes are starting to move. So now I will enlarge this file. I will not be able to see your comments now for a while, because if I minimize this file or make its size small, then lines will overlap, you can see. So it will be tough to understand. So I will maximize this screen. Okay, now see it. I told you yesterday, now you don't have to learn everything. Okay, what you will have to learn? Only some things that is required for your parameters calculation. Suppose if you are requiring delay, then what will be there? For calculating delay, the node ID you should know and the time you should know. And when it is the event, means it is sent or received, this thing you should know. And at which layer it is received or sent, that you should know. Okay, nothing else is required. Okay, so for calculating delay, only that thing is required, nothing else. So in trace file, many things are there. So you don't have to learn everything. Whatever you require, only those things you will have to learn. Okay. So S means send. Okay. 5, obviously time, we started the transmission time from 5 seconds. Now the third one is 122 is written. 122, now you check the row. Is any number greater than 149? No. In this row, in the third row, no number is greater than 149. It means what? This may be the node ID. So it is the node ID. AGT, I will tell you this. AGT is application layer. RTR is routing layer. PHY is physical layer if it is written PHY. MAC is medium access control layer. Like this, it is defined. Okay. So, what it is, what this line says that a packet is being sent at 5th second from 122nd node, from the application layer of this node. Okay. This is the TCP. This is a TCP type of packet, and this line is, because it is generating it in a sequential manner, it will be what? It will be packet ID. Okay. And this is the packet size 40. Okay, I have not provided packet size manually, so it has taken the default value 40. So after you, in this line, after some time you can see, okay, this is another thing. The trace files are too large actually. If you see, total 75,000 lines are there. Okay, this is some packets are being sent of 1040 size, byte size, means like this. Some acknowledgement size is 40 bytes. Okay, like this, many things changes according to the scenario. Now leave it for now. I will tell you further steps. Sender 5 second, 120 second node, application layer, 0 packet ID. It is a TCP type of segment, TCP segment. 40 is the size of the segment, and 0000, what? These are some flags. Okay, so they all are 0, no use of it. This is the energy. Energy is what? I have defined the energy. If you want to calculate how much energy is present at the end or how the energy is being reduced according to time, you can check this line. Suppose energy is what? 1 joule. I told you in the scenario the initial energy was 1 joule. So initially energy is 1 joule. Let us go randomly at any time. Here the energy has been reduced. Why? Some transmission has been taken place. See the energy of this node, 0.2554. It means that it is transmitting some data, okay, or receiving some data. It is either transmitter or receiver. Okay, that is why the energy is draining very fast. This node is what? You can assume it is neither transmitting the data nor receiving the data, but it may be acting as an intermediate node. Okay, maybe and may not be possible. It may be draining the battery just to. Okay, now it actually some packets it will have to forward, otherwise this will not be changed. Okay, now like this. Okay, you can see for everything. Okay, let us come at the top. So only these things, packet is being transmitted or received at what time, from which node, application from which layer, what is the packet ID, what is the data type or packet type, what is the size, and what is the energy. Only these things are required for you to calculate anything. These are the same thing. 122 packet ID means this is 122 packet IP address and this is the port address. Okay, this is 123 IP address, this is the port address. Okay, and this thing shows the MAC address, this thing again shows the MAC type. However, you don't have to go into the details. Okay, these things are not required, only these much things are required. But understand this carefully. This trace file is not used nowadays. There is a slightly means there is a huge modification in it. So one new trace file is created. Okay, is there any script to interested values from trace file? Means to get interested values. Yes. There is no script, but you can make one. Okay, the AWK script does the same thing, whatever you are saying, but it does not take these values from the trace file. It just read those values and calculate analyze those values to calculate the final data. Okay, final output, the delay or throughput or anything. Okay, so this is the trace file for wireless scenario. However, I will tell you, learning the format of trace file will not help you. Okay, why? Because the trace file is different from different type of network. Okay, so they may be same too, but generally they are different. But a new trace file is created, okay, to make all the trace file is similar. If you see the TCL file, in TCL file I commented one line, use new trace. Now I will uncomment it, use new trace. I will uncomment it and now I will run the program. Let us see what happens. Some scenario is generated. I will close it. We have already seen it. The interest is in trace file. So a new trace file is generated. Now see the format of this trace file. There are many methods means many variables are there. PS, PO, PS, TCP is written here. Like this it is there. So there is no need for all the files. Means all the variables you should know, because it may be different for, it may be some value, suppose PS, PA, PM may be used for some other protocols and might not be of your use. Okay, so like this you will have to work. And you don't have to study this trace file. For the simplicity, someone has developed an AWK file. I don't know his or her name, but someone has developed an AWK file regarding this script, regarding this trace file. So that particular AWK file I have provided you. However, some changes in that AWK file is required, not for you. If you want to run any new protocol and anything else, then some changes might be required in that AWK file. Okay. So now the things have started to begin a little bit complicated. No problem in that, because we are just about to finish our, means not webinar. Webinar I will be starting, but whatever the content I wanted to deliver to you, I have delivered almost. Okay, I have shared it on Google Drive. Okay, I will send a mail to everyone of that link to the Google Drive. Okay, so I will send it again today. Okay, but the webinar is not ended yet. I will keep you telling something. No problem in that, because related to source file and these things. Okay, if you want to learn, then you can stay. Okay, and after this I will, on the WhatsApp group, I will send you a feedback form and an attendance form. So attendance form is nothing but so that you can write your name correctly on it. Okay, name and your email ID you write correctly, because from that only I will be creating the certificates. Okay, so please write the correct name and email IDs in that file, in that form. Okay. Okay, so let us continue. The trace file I sent you. Let us, the AWK file, sorry, I sent you. Let us run that AWK space -f space wireless.awk. That is the name of that trace, that AWK file, and the name of this trace, the trace file generated by this scenario is this. Okay, see this one, what it is written here. Since it is a very large scenario, see the condition of this scenario. 350 packets could be transmitted. Okay, and only 28 packets were received. Packet delivery ratio is 8% only. Okay, and control overhead what it is? 1961. Means 1961 AODV packets were sent to transmit only 8 packets. Okay. Because this scenario is very complicated, that is why it is showing the results in this way. Otherwise it will be showing very good. Means I have created the scenario just to teach you. Okay, so yes. Okay, and normalized routing overhead, what it is? Normalized routing overhead, it is ratio between packet, the control overhead and packet delivery ratio. Okay, so if you divide 1961 by 28, since 28 packets are received and 1961 AODV packets are received, so that is why if you divide 1961 by 28, you will be getting 70. So there is 70, overhead is 70 times. It is not the case in any network generally. So it is just in our scenario. The delay is 0.79 seconds. Okay. So 790 milliseconds is transmitted, is the average transmission time to transmit a packet. Throughput is 1149 bytes per second. Jitter is 1.58 seconds. Jitter, I think you already know. These things are the common performance matrices of any network. Now, total energy consumption is this much of energy is consumed. Average energy consumption is this one, 11 divided by total number of nodes. and overall residual energy is this one, average residual energy is this one. It is overall divided by number of nodes. Okay, so this much of energy is this much of energy is remaining, and this much of energy is consumed. Okay, so like this is the complete analysis of your network. Since we have defined this scenario as completely random, so if I run it as many times as I will run it, I will be getting all the values different. Okay, so let us see. Now I have this is a quite improved values. Okay, so out of 800, one packets 465 were transmitted. Okay, here only 28 were transmitted. Why? Because the scenario is random. So in the first scenario, it might be the case that a receiver was distant from the transmitter. Okay, so in the next scenario, most of the receivers are close to the transmitter. There may be direct path. Okay, so like this, throughput is also good, jitter is less, number of packets dropped are less. Here number of packets dropped are high in comparison to what has been transmitted. So like this. Okay, so this is the completion of what I wanted to teach you, or what I wanted to share with you. Now I will proceed towards a simple things. Okay, something regarding the source codes as well as some Ubuntu thing. In Ubuntu you should learn something. One command is Control C. Okay, if you press Control and C in your terminal, that you will be stopping the current ongoing process. Means if some process is running, like see this, here I am running this scenario. See at the end, here this type of line is not written here. So some process is still running. So what we will have to do, before entering any command, first terminal should be free. So press Ctrl C here. So the existing process will be over. Okay, so the NAM window is also closed. Okay, so if you want to open the NAM window again, you can write NAM, the name of the NAM file, and just press enter. Again you can see this process is running. If you do not close it, then you cannot type any other command. Okay, so Control C is an important thing. Now, okay, this thing is okay. Now let us see what is a TCL hook. Okay, TCL hook is, let us open our wireless scenario. Trace file is over, so I will close it. See here, I have used AODV here. Why I have not used small AODV here? I have used this particular thing here, these keywords here, these things here. But why I have not used something else? Why I have written O capital? Why not small? So there is a reason behind it. Because in source code, it is necessary. It is defined in this way only. So how you will find the source code for this? Okay, so I know the locations of the source codes, but I will tell you how you search anything. Copy. Suppose you want to search this one. Copy it. I told you yesterday to install Search Monkey. Open Search Monkey if you have installed, and if not, no problem. You can only see. In Search Monkey, from this button, go to the folder from where you want to search. So all the source code is written in this folder, NS2.34. Go here and click open. Now you want to search what? This, where it is written MAC /802_11. and you can make it case sensitive as well. Okay, match case. Okay, and search. Let us see where we get it. Some files have come. There may be a lot of other files too. Now see how many files have come. There is one TCL file. So TCL file is not a source code. So see here. One CC file is there. CC file means C++ file is there. And others are TCL files. So only CC file has the source code. Some things related to source code are written in TCL files also. But that we have to change in CC files. So let us open. These two CC files are there. Let us open it. It won't open from here. You will have to check its path. What it is written here? Home, this. In NS 2.34 folder, Mac and Mac 802_11.cc. So let us go in this folder. Home. Okay. And NS all-in-one. NS 2.34 Mac folder, okay, and Mac 802_11.cc. So here it is. So you can see whether the same command is written here or not. See here, Mac /802_11. It is called the TCL hook. Okay. So thus whatever is written here, only you will have to write this thing only, nothing else. Okay. So this is how you find anything in your computer. Now if you don't know the TCL hook, means this you don't know. If you want to search for anything else, suppose randomly you want to search for anything, suppose for IPv6 you want to search. So there are a lot of commands present in that IPv6. So you can go and search IPv6 and remove the case sensitive option here, because I am just normally searching. Let us see where IPv6 is written, in which file. Okay, it is closed, hanged. Search monkey. Okay, I will open it again and let us try to search. Okay, these are some extra things I am telling you. These are necessary. The search monkey is not getting open now. Yeah, okay. It is open. So let us search IPv6 in this folder. Let us see. Oh, there are so many files. Okay, because we have searched the general term IPv6. So it may be present in many files. So, but we will have to see only the CC files. Okay, not other files. However, there are a lot of files in it. So you will have to search in these files. But to search these files, it will take a lot of time. So what you can do, okay, in all the file IPv6 keyword was used. Now let us see whether a file is named IPv6 or not. From I, let us see IP. IP.cc is written here. Okay, no. Only IP.cc is here. IPv6 is not written here. So let us see what is inside the IP.cc file. So let us see its position, where it is stored in the computer. Okay, it is continuously searching. I will stop it, no problem. So let us see IP. Where is IP? IP.cc. It is inside common folder. So where is the common folder? in this folder, common folder is here. Okay, so let us see where is IP. IP is this one. So let us search IPv6 is written here or not. IPv6 is not written here, but let us search. Okay, it is a very small file. So let us open its corresponding H file as well. IP.h. So try to search is IPv6 here. Yes. 3. It is appearing in 3 places. IPv6, IPv6, IPv6. So if you know the theory of IPv6, so these things may be there.